Hey, hello everyone. I'm starting today's lecture by welcoming everyone. This is the fourth class of our GM over ID tutorial series. So today is basically our tutorial number 4. In the previous tutorial, we saw how to extract the required parameter from Cadence. So our required parameter was GM by GDS, then ID over W, then GM over ID, then VD set, then VOV, that means overdrive voltage, then FT, then finally FT into GM over ID. So the last class actually we extract this one, this one, this one, this one, and this one. So remaining thing is this two. That is, we will extract today at first the VD set and then the VOV. We saw how to extract the required parameters from Cadence. However, the parameter were plotted with respect to VGS. If you recall, your all the parameters, there's all the parameters in y-axis, and your x-axis is actually GM over ID. Sorry, not GM over ID. It is actually about your MOSFET's gate voltage, that is VGS. So this is the by default curve. The cadence is actually generate. Right. So, but the plot we actually need in the variation of different parameters with respect to GM over ID. So we need in the x-axis as GM over ID, and at the y-axis the parameters. This can be done in Cadence, but when I analyze the different channel lengths, so it will need to use parametric analysis. So we will do today parametric analysis. Okay. That means I will vary the length by length of the MOSFET and observe what result I get for each length. Suppose you plot VGS of n, and the y-axis is actually your, suppose, GM over ID. So we actually try to plot different length. So this curve may look like this. So something look like this, for example. So now when I plot the curve for many different lengths togetherly, this, you see here, this graph will become quite cluttered and complex to understand. So if I plot this curve with respect to VGS of n and varying my length for, let's say, for example, just only for GM over ID. Let's have a try. Okay, how the curve will look like in Cadence. Okay, so let's see how this looks. So this is my diagram actually that I'm using right now. So if you go to the ADEL and just plot for GM over GDS. So we need to unselect all the things, just GM over GDS. Now you can see here you are considering your length is 45 nanometer and width is 120 nanometer, just a single length. So whenever I run the simulation, it will simulate for just this single length. ठीक है sir, for this single length. So we need the length variation. For this reason, we will do the parametric analysis. So in parametric analysis, you have this type of box. So this column first element is for your variable. So we have several variable in our schematic. So we need the length as a variable because we define ln for length variable. The initial value that I'm giving, that is 45 nanometer, I will sweep the value. So click on it from 100 nanometer to 2 micro. You can easily change your uh, maximum value. Let's say 5 micro. Let's try to see what will happen. Step size will be linear steps, and the incremental factor, say for example 500 nano. Each time whenever the data will increase 500 nano times, it will increase. So let's click enter. Now we need to need to save this one. So run the simulation. All right. So now you can see that your VGSN is plot with respect to game over GDS, and you feel like this type of curve here for different lengths. So these are your different lengths. You have this type of curve. So the curve is actually very near by each one, right? So one from one curve to another curve is very nearly. So which is your perfect length? You cannot understand this properly. If I decrease my step size, let's say for example 200 nano, then you can understand these things very easily. I'm using here now 200 nanometer step size. So now you can see the situation in here. So this is very complex to understand the curve. If you try to zoom this, then you may make a decision, but this is actually not a good solution. So we will do that. That is, we will do the parametric analysis for all these parameters and for different lengths. Let's see what will happen. And run the simulation. So now you can see here the all the curves with respect to different lengths. Suppose you try to study the GM over ID versus gate voltage. So go to the rectangular. So you cannot actually understand what will happen here. So that's a problem. You cannot make a good decision from this curve. So you need to generate this curve with a different software. That software can provide you a sort of like good looking curve, which curve when you see you can understand what will happen and which is actually the characteristics the component actually implies from his side. You can understand this uh, by observing the curve in a different environment software, like it may be MATLAB or any other software. Okay, so we can observe this scenario that is, it is actually try to difficult to understand the curve. So guys, we can understand the problem. That is, curve is actually not understandable. So we need a clear, nice curve. So for this reason, we will extract our parameters in such a way that is .dat file. We will generate the .dat file for all the parameters. All the parameters we will generate that file for them. All right, so we will create .dat file, and after that we will modify little bit modify in the .dat data. Sorry, .dat data. So whenever you generate the .dat data, you can easily plot those data. There are several software you have, several options you have. So if you have some data, you can easily plot it into the Excel. You can also easily plot this data in origin. You can easily plot this data in MATLAB. And then you try to interpret those things. But I will show how to plot the DAT files in such a different way. But the question is that what we'll do by using this DAT data. So suppose we will generate these all the parameters DAT file. Let's say GM over GDS, its corresponding DAT file. Its corresponding DAT file. And after that, you have the VDSAT dat file .dat file, and then you have ft versus ft.dat file. If just ft's dat file, you have suppose ft into gm over id .dat file .dat file. You have to do the vov corresponding .dat file. Then you need gm over id its corresponding .dat file. And finally, you need, say for example, for id by w, its corresponding .dat file. So now you have all the .dat files, for example. Then what you do? You will use a software that can plot data. Okay. So suppose you have a gm over gds .dat file. So you have gm over gds .dat file, and you try to plot this .dat file data versus gm over id .dat file. So gm over id .dat file. So what will happen? The software is basically ready to plot for you. You will define in such a way in the software, your x-axis will be gm over id. So it will fit the gm over id datas in x-axis, and you define the gm by gds .dat. This data will work from y-axis. So the software will generate you the gm over gds versus gm over id curve, and you extract your all the parameters value for different lengths. So you will see your curve such a good outstanding looking, but it is not too very easy. You need to do some crude level programming there, and by using those programmings you can actually easily generate a very good looking curve. So basically I will teach you how to plot .dat file in overleaf or latex. How do we can plot our .dat file in latex? So basically this is the outline of today's class. So our first objective is finding the VOV versus VGS of n. Second of all, we will find out the VD set versus VGS of n. And after that, we will do the parametric analysis. Then ready the .dat file for all the parameters and do a little bit Ocean script in there. We will do some Ocean scripting. Okay, so let's go to the Cadence again. So welcome back again in the Cadence Virtuoso. So I already add here my VD set and overdrive voltage. So if you see the expression of the VOV, that is, you need to subtract VGS from VTH. So this is the expression. Just add it and write down this as a VOV. After that, you find out the VD set from your result browser and then add it. So now we will do the parametric analysis for, let's say, for example, for 4 micro, and run the simulation. All right, so you can see here all the curves. This is for ID by W. So this is for your ID by W curve for different curves. So now we will do ocean scripting. For the reason, we will go to the file and save ocean script and give a name. Let's say we'll give the name as inmos length underscore para underscore gm over ID. Okay, we will write this name and then apply and then okay. So you see here this is gedit, but you will not do something here. Directly you close it. So you need to go your directory where you launch the Virtuoso. So go to the work home and my directory is gm over id. So in this directory my file will save. If you see here, there is nmos length param over gm over id dot ocn. So let us open this one. So if you see here, we will plot the expression and the data, and this will do for my parametric analysis length values. Our variable we set those. So everything is we get as a programming environment file. So we not need to the plot file. So we can remove our plot. So go to the ADL and select all things, and we will select disable plots. And after that, we will again uh, run the parametric analysis. So let's run. So this is done. Now we will go to the file and then save ocean script. Same place. Overwrite. Okay. So close them and go back your directory. So now you see here your inmost parameter gm over id. Sorry, this is actually our inmost length parameter, then gm over id dot ocean. So now you can see all the plots are actually disables. So you need to do a programming here. You need to write here OCN print, then output with the address of your directory. So the address of the directory is work home slash gm over id. So let's copy this address. Use a quotation sign here. And now set a name. Let's say nmos underscore. Let's write all the letters in capital form. id slash w dot dat. Then quotation is closed. Use a question mark. Then write number, notation, scientific. scientific, then use your variable, that is id by w. So you need to use the id by w as your name. So let us write, then close the bracket. So this line will generate the dat file for id by w, but we need the dat file for others parameter. So we will do just simply copy this one, and now we will edit them. So second thing, I need the FPGA over ID, for example. So I rename this name. Just do copy and paste now. Very easy. Okay, fine. So now we will copy this to row, and then we will work for GM by GDS. And then work for FT. So okay, ft.dat, and then we will change here. This is as a ft. Then we need to copy again. Now we will find for GM over ID. And so from here we need to GM over ID. And then we need to for overdrive voltage. That is the BOB. And here we will also use the BOB. And finally we will do for V reset. So let's do for the V reset. Okay, fine. So this is for ID by W. This is for FTGM over ID. This is for GMGDS. This is for FT. This is for GM over ID. This is for overdrive voltage. And this is for the V reset, saturation voltage. Now save it. So basically this is the name of my Ocean script file. Let's delete this one. So let me just create a new folder and name it is as a .dat file. .dat file. And now press enter. So we can see that the successfully everything is extracted. So we make a folder for .dat file. We need to save our .dat file. So you see this is your FT, that is transient or the GBW .dat file. So let us copy it. This is FT versus FT into GM over ID .dat file. This is NMOS GM over GDS, GM over ID .dat file, ID by W .dat file. Then we have vreset .dat file, VOV .dat file. And I think everything is I found here. So let's cut and go to this folder and paste it. So you have 7 .dat file here, right? So if you open a dat file, so for example for FTGM over ID, so you can see that all the datas. the combined set. So we will actually use this data in a software, and then by using those software, we will actually plot the parameter versus GMO variety. And then we will interpret that curve. So that's our main objective. So this is the content for today's class that I'm covered. So the next class, I will use this .dat file in LaTeX and try to show how to plot .dat file in Overleaf. And with these, I conclude this tutorial. So thank you everybody.